Hey guys again. It is just so that we don't forget which date it is. This is our math lesson for March 19th and today's Thursday. So make sure that you're watching this one, hopefully on the same day. If you are a little behind, obviously that's okay. But just make sure that you do end up watching the videos because it's definitely gonna help you continue learning. This is gonna be our math workshop lesson. I'm going to be sharing my screen with you in a second. Let's see. Yep. Share. Okay. So I'm going to go to our Google Slides. We're going to start with, like we usually do, our learning intentions, if I can get to it. Here we go. And our learning intentions for today, for math workshop. Today, I will continue to solve two-step problems that involve multiplication as well as addition and subtraction. And a second intention for today is that I can use a strategy to multiply by 12. Success criteria, I can solve multi-step problems. I can use a strategy to multiply by 12 efficiently. If you recall, yesterday we worked on multiplying by 11. And this is just going to be a continuation of us solving multi-step problems. Language intention, I will use vocabulary words from our anchor chart to answer questions. I know we're not in class. I recreated our anchor chart on Google Slides, so we'll go over that in a moment. And then social intention, I've been saying the social intention for almost every video. I will do my work even when no one is looking. So just remember that this is your education and we don't want you guys to lose out. Just because you're not in school. So please make sure you're trying to do as much as you can. We're going to start with our anchor chart. And typically when I do this in my class, and I'm sure with your other two teachers, I do the vocabulary drill, we say the words together, and if I do a gesture, you can do the gesture. So say it with me: multiply, equal groups, also number of groups, group size, multiples, factor times factor equals product, equation, commutative property, and we know that commutative property means that, and I just noticed there's a little mistake, and I want to fix that. That is meant to be an equal symbol. We already know that the commutative property means that it doesn't matter the order of the factors, like you can switch the factors around and it's still going to give you the same product. For example, 4 times 2 is the same as 2 times 4, right? Or 4 equal groups of 2 is the same as 2 equal groups of 4. And as mathematicians, we can change those factors around to just make it a little bit more easier for us to solve. Because it'd be easier for me to solve 2 equal groups of 4 instead of 4 equal groups of 2. Associative property, which we started talking a little bit last week before we went on break. And I started talking about it a little bit, I think, yesterday. But associative property means, again, very similar to commutative property. It doesn't matter which numbers you multiply first, you're still going to get the same product. So if you have an equation with more than 2 factors, for example, I have 3 times 2 times 2, right? I can multiply 3 times 2 first, which gives me 6, and then times 2, that's going to give me 12. Or I could also do 3 times 2 times 2, right? It looks very similar, but maybe I'll start multiplying 2 by 2, 2 times 2, and that gives me 4. Then I multiply that by 3, that gives me 12. And so again, that's associative property. It doesn't matter what numbers are in parentheses first. You can multiply it regardless. And then the word efficiently, we always talk about. And then a sentence that I would like for you guys to really use a lot is, I think the product is because we have the word array, right? We have rows, horizontal, and then we have columns, which are vertical. And some of the models and strategies that we always use, or we started using more so at the beginning of the year: repeated addition, skip counting, an array model. For example, I have my array here, very similar to what you're going to do in 4th grade, which we say array, also area model. We have, right, this would be our height, so we have 2, and then our width would be 3, so that's 2 times 2 would give us 6. And one strategy we've been really pushing for is decomposing. It's decomposing is a very, very efficient strategy, especially now towards the end of the year, and you're going to see in 4th grade that you want to know how to decompose well because you're going to be multiplying larger digits. So I have 15 times 2. I decompose the 15 into a 10, and I decompose it into a 5, and I had to multiply it by the other factor. So 10 times 2 is 20, and 5 times 2 is 10. And then remember, I have to add those products together, so 20 plus 10 would give us 30. So now that we've gone over our anchor chart, we're gonna go into our do now. So for our do now, I'm gonna ask you to pause in a second. I know this is hard to do because you probably don't have any graph paper at home, but I am gonna ask you to pause and to try to draw out this polygon that I've drawn out in your math notebook. So if you don't have your math notebook out yet, go grab it and pause so that you can just draw this irregular polygon. Make sure that you have the correct amount of square units and that it looks almost the same as mine. So pause now. Okay, that means you're back. You've already drawn it in your notebook. So we're going to be looking at the area of this polygon. First of all, let's figure out how many sides it has. Like, what kind of polygon is it? So if I start counting the sides, I have 1, 2, 3, 4, 5, 6, 7, 8. If it's 8 sides, it means that it is a, yeah, if you said octagon, awesome. Doesn't look like your regular octagon, so it must be an irregular octagon that we have here. And if I look at my key to the side, it says that a little square represents 1 square unit. Okay, now the question is, can I decompose, there's that word decompose, right, when you break apart, can I decompose this polygon in order to find the area more efficiently? Think about it. Look at that irregular octagon, and is there a way for us to break it apart so that it's easier to find the number of square units instead of going one by one and counting each of those square units? I want you to think. Okay, thumbs up if you have an idea. And I'm gonna let you go solve this on your own before I show you how. I want you, underneath your irregular octagon, I want you to write the statement, I think the area of this polygon is because So pause it so you can go solve. All right, that means you're back, you've tried solving. We're gonna do it together right now. I'm gonna share a different screen with you in a second. I just wanna make sure I have everything I need. Let's do this. Let me go back to this. And give me 1 second as I'm trying to figure this stuff out. I'm gonna stop share for this one. And I'm gonna share my other file, which looks like this. So now you should be able to see my smart file. Okay, so let's decompose this irregular octagon. There's a lot of square units in there, but I definitely think I see a square in there. So I'm gonna grab a different color. I'm gonna do blue. Let me see how thick that line is. That's a really thick line, so I'm gonna make it a little bit thinner. It's easier to use. I'm gonna use blue. So let's see. I'm going to draw this out. So I'm gonna separate the square that I see. Actually, it's not a square. I see a rectangle. Do you guys see that? See how I'm separating that? So now I have in the middle, I have this rectangle, and I know that I can find the area of a rectangle because I know I have to multiply, that's right, I have to multiply height times width. So I'm gonna start writing out an equation. So let's do, let me see, what's my height? 1, 2, 3, 4, 5, 6. So 6 square units that way. I'm gonna put that in parentheses and move this up here. So I have 6 times, and I'm gonna look at my width. I have times 4. Okay, but I can't forget about my sides. I have some other little square units on that side that I can't forget about. Let's see, I have 1, 2, 3, 4 full square units on this side. If I have 4 full square units on here. I must have 4. Yep, I do. So that's an additional 8 square units. And I'm almost done, but careful because I have some halves up here. I can't forget about those halves. I know that if I put 1/2 plus another half, that's going to give me a whole. So here's 1 whole. So here's a half, that makes 1 whole. Plus another whole, here's a half, another half, that gives me 2 wholes. So now I'm going to add 2 at the end of my equation. That's weird. Hold on 1 second. There we go. Okay, and now I can solve. So I'm gonna grab a marker. And then let's solve. I know 6 times 4 is 24. And I'm not gonna do plus 8 plus 2 because I know 8 plus 2 is 10. So 24 plus 10 equals 34. And so our area equals 34 square units. Okay. All right. If you got 34 square units for this problem, give yourselves a pat on the back. And if you didn't, this is your opportunity to go back and figure out where did you make that mistake. So if I go back to my statement, I think the area of this polygon is 34 square units because I decomposed the irregular polygon into smaller shapes. That is one way that you could have written your response. We're going to go into reviewing solving multi-step problems. And give me 1 second. So we're going to go into reviewing multi-step problems right now. If it lets me delete this, let me see. It does not let me delete. Okay. So we're going to start by reading the story. Flora is helping Mr. Jackson get ready for a family math night. 8 families are coming. Flora needs to count out 4 square pattern blocks and 3 triangle pattern blocks for each family. How many pattern blocks will she count out in all? Question A is, what is this problem asking you to figure out? Underline any information that can help you solve the problem. You don't have the problem in front of you and you don't have to rewrite it, but you can write down key information. What are some of the numbers you see in the problem? And then what is it asking you to do? So you might write something like, I think this problem is asking me to, because, I'm gonna make that a little bit smaller, guys, because that is very big. Yeah, so I think this problem is asking me to because and then it says choose the equation that best represents this problem. The letter P stands for pattern blocks. Look at your options. We have option A says 4 plus 3 plus 8 equals P. Does that equation represent the problem? Second one in parentheses, we have 4 plus 3 times 8 equals P. We have option C, 4 times 3 times 8 equals P, and then option D, 4 times 3 minus 8 equals P. So I'm gonna ask you to pause and try to solve on your own. Okay, that means you tried solving on your own, and now we're back. So I'm gonna reread the problem again, and I'm gonna answer part A. Flora is helping Mr. Jackson get ready for family math night. 8 families. Key information, right? We have 8 families. I'm going to underline that. Let me see if I have my handy dandy highlighter. I do. So family night, 8 families are coming. Flora needs to count out 4 square pattern blocks and 3 triangle pattern blocks for each family. And then the question is asking me, how many pattern blocks will she count out in all? I need to figure out how many pattern blocks will she count out in all. Okay, before I even choose an equation, I want to try to come up with the equation myself. So I know, let's see. I know I have some information already. I know that there's 8 families and that each family needs 4 square pattern blocks. That meant when I think of the word each, it makes me think of, well, equal groups, right? We have families, we have 8 families, 8 equal groups, and they each need, so there's our group size, they each need 4 square pattern blocks, and they each need 3 triangle pattern blocks. And then this equation is really gonna allow me to figure out how many pattern blocks in total? Okay, so now I have an equation. I have 8 times 4 times 3 equals P. And now I have to look at choosing the equation that best represents this problem. Let me look. Is there one that looks exactly like the one I created? Thumbs up if you see it. And then another thumbs up if you can eliminate some of them. Because I'm looking right now at option A, it says 4 plus 3 plus 8. That doesn't look like it's right? We're not adding. So I'm going to grab my other marker and let's eliminate that one. That one does not look right. Let's choose a different pen. And let's choose pen. I'm going to cross it out. So definitely not the first one. And then I'm looking at another one. The last option, 4 times 3 minus 8. That doesn't look right either. And then we have 4 plus 3 times 8. 4 plus 3 in parentheses would give me 7 times 8. I'm going to leave that one for now, but one that does really look similar to mine is 4 times 3 times 8. And if we think back to associative property, it doesn't matter the order of the factors or the way in which we multiply first, it's still going to give us the same product. Let's try it out. So instead of saying multiplying 4 times 3 first, I'm going to multiply 8 times 4 first. 8 times 4 gives us 32. And then I have to multiply that by 3. And that's a larger number. I could do 32 plus 32 plus 32, that's repeated addition, or I can use decomposing. So I'm going to decompose this into, let's do a 20. Let's do a 10. And let's do a 2, right? I'm going to type this because it might be a little bit easier for me to type. So I know 20 times 3, 20, 40, 60. 20 times 3 gives me 60. Make it wider over here. Let's see, I've already did the 20. Now 10 times 3, that gives me 30. And then I have one more factor to multiply. I have 2 times 3, and that gives me 6. So let's look. I'm going to add my products together. 60 plus 30 plus 6. That would give us 96. So our product equals 96. All right. Well, that's one way to solve it, but they have another equation up here. It looks very similar, but the factors are in a different order. So I'm going to try doing that one as well. Let's do 4 times 3 times 8. Let's see if it matters. Let me see. What if I'm going to start multiplying 4 times 3 first. I'm going to put it in parentheses. And I know 4 times 3, 4 times 3 is 12, then 12 times 8. If I don't know my multiples of 12 yet, I'm going to decompose again. So let's do our marker. I'm going to decompose that 12. I'm going to do it into a 10 and a 2. And I know 10 times 8 equals 80. And 2 times 8 equals 16. And when I add my products together, it's going to give me a total of 96. So as you can see, it doesn't matter the order in which you multiply, it's the associative property, right? It's still going to give you the same product. Thumbs up if you're able to get that one. And if you didn't, remember you can rewind. So we're going to do one more thing for today, which is one of our other learning intentions, is learning how to multiply by 12. If you haven't memorized your multiples of 12, that's okay. It's always good to have multiple strategies. So for multiplying by 12, Mr. Miller says he has an efficient strategy for multiplying by 12. He says he can use the distributive property to solve. For example, 12 times 5 is the same as 10 times 5 plus 2 times 5. Do you agree or do you disagree with Mr. Miller's thinking? And I want you to write in your math notebook, I agree or disagree with Mr. Miller because, make sure you're writing a juicy, juicy sentence for that. So pause so that you can do that in your notebook. Okay, and we're back. So let's see. Let's see if we agree or disagree with Mr. Miller. I'm trying to figure out what he did here. He says that he's using the distributive property, and I'm like, wait, have we used that word before in class? I don't think we have. That looks like it's a new juicy math word. But let's figure out what the distributive property is by looking at his example. He said 12 times 5 is equivalent or equal to 10 times 5 plus 2 times 5. And it looks like he took the 12 and he decomposed it into a 10 and then into a 2. And that he multiplied both of the numbers that he decomposed by 5, which is the other factor. Let's just double check that he's right though. So if I multiply, I'm going to use my typing again. If I multiply 12 times 5, again, I can, let me see, I can decompose the 12 into a 10. Let's do that. I'm going to use a marker for that one. I can decompose that into a 10 and then into a 2. 10 times 5 is 50. And then 2 times 5. I'm going to cross that out so I don't get confused. 2 times 5 equals 10. That gives us 60. So we know this side of the equation, 12 times 5 is 60. Well, now we want to double check that his strategy is correct, that this so-called distributive property works. I know 10 times 5 is 50, and then 2 times 5 is 10. And if I add those together, it gives us 60. Wait a second. If you're scratching in your head and you're like, Ms. Maldonado, that sounds very familiar to what you just did when you decompose 12 times 5, you're absolutely right. I've been teaching you distributive property all along. We just hadn't used that juicy, juicy word. So when we decompose, it's very similar to distributive property. It's essentially the same idea. We use distributive property or decomposing so that we can efficiently multiply larger numbers. So if you wrote, I agree with Mr. Miller because what Mr. Miller did was decompose the 12 into a 10 and then into a 2 and multiplied it by the other factor to get to the product of 60, then you are correct. And we're going to be trying this distributive property a lot from this point on. We're actually going to ask you to pause again, and I want you to try out this bonus. Try using the distributive property for 12 times 7. So 12 times 7, that's a really bad X for multiplication, but 12 times 7 is the same as what factor times what factor plus what factor times what factor. So 12 times 7. So go for it, pause, and then come back to me. Okay, if you said 12 times 7 is the same as, let me use a different color. If you said 10 times 7, and then I decomposed that 12 into a 10, and a 2 times 7, then you are, because 10 times 7 is 70, and let me use a different color. So 10 times 7 is 70, and then 2 times 7 is 14. My brackets are all ugly, so I'm so sorry, guys. 70 plus 14, that would give me a total of 84. So if you got that, give yourself a big check mark. For the last part of this math lesson, I want you to try it out on your own. So I'm going to stop sharing this file to show you your independent work for today. I want you guys to try using the distributive property for the following equations. We've already done the first one, so don't worry about doing the first one, but I do want you to use the distributive property, I say, you say, distributive property for this equation that says 12 times 8, 12 times 9, 12 times 10, 12 times 11. And so you are 100% certain that you're doing it correctly. Do the distributive property first, and then you can go to each of these equations and decompose it how we typically decompose, just to make sure that you are multiplying correctly. In our YouTube, or on our YouTube comment section, just take one example from one of these equations and show me you understand distributive property by typing out your answer. So let's say you choose 12 times 9. You're going to write 12 times 9 equals times plus times Make sure you use that parentheses, because that's very, very important for you to use parentheses. And I just realized, sorry guys, I just realized I forgot to share the screen. So I'm going to say that one more time. I'm not going to say everything again, but here are the equations that I want you to use. I want you to solve in your notebook. Again, you don't have to do the first one, but you are going to solve. You're going to use the distributive property for the rest of these equations. Just choose one, and in the comment section, you're going to show me that you understand distributive property. So you might say in your YouTube, on your comment section, I understand distributive property because 12 times 9 is equivalent to in parentheses times plus in parentheses times equals Right, that is the only independent work that I'm giving you guys today. Let me know if you have any questions. Remember, your parents can message me. You can send me an email. You can send Ms. Delgado an email. You can send Mrs. Alonso an email. Bye, guys.